Hello everyone, in this video I'm going to continue to talk about multivariable calculus, and I'm going to discuss calculus with parametric curves. So first let me give you a motivational example. Let's say I'm giving these parametric equations and x equals cosine t and y equals sine t, where t changes from 0 to 2 pi, and as we know by eliminating the parameter, the graph of this parametric equation is a circle. And my goal is I want to find for which values of t I will have either horizontal tangent lines, so in this case I can see I will have these two horizontal tangent lines, or I will have vertical tangent lines. Okay, so based on this example, we actually can find our t really easily, because when t equals to 0, I have exactly point xy equals to 1, 0. So this is going to be my initial point. So we can see that at t equals 0, I exactly going to have this vertical tangent line. Then this point you can check correspond to t equals pi over 2. This point is t equals pi, and this point t equals 3 pi over 2. I like this example because it's easy and we can guess the answer based on from the picture. So the answer for our question for which t we have horizontal vertical tangent lines for this graph are exactly t equals 0, pi over 2, pi, and 3 pi over 2. Again, we got this from the picture. But let's say we're given another difficult parametric equation. How are we going to do this in this case? And in this case, we're going to use calculus. So let's redo this problem by using calculus with parametric curves. We know that from single variable calculus, when y equals f of x, if we're going to find the y prime or derivative of f prime of x, it's exactly going to be the slope in our graph. So if we have some graph of function y equals f of x, if I have that slope equals to 0, so in this case slope 0, from here it's true if only if f prime of x equals to 0, or in other words, if my derivative equals to 0. So in this case, for this problem, what do I need to do? I want to take my parametric equations and I want to know how I can find the derivative of my parametric equations, or in other words, I want to find the slope of my parametric equations. But the problem is here I can see that x depends on t, y depends on t, and I only know how to find the slope of a single variable function, which in this case is y equals f of x. But let's derive the formula for the slope for parametric equations. We can see that I'm looking for f prime as y depends on x. But in our derivative formula, we have that y is on the top and x is on the bottom. But since our x depends on t from this expression, and my y depends on t, so what can I do with this formula? I can take top and the bottom and divide by the same factor dt. So we have dy over dt and dx over dt. And we can see right now in this formula that our y depends on t and my x depends on t. So what can I do actually? I can find the derivative of function x and function y corresponding to t. And this is exactly going to be, sorry I cannot erase this, and this is exactly going to be the formula for finding the slope for parametric equations. Or in other words, derivative of parametric equations. Okay, so in this case we have a formula that if you want to find the derivative, you just need to find dy over dt and dx over dt. So let's find for this example what is my dy over dt and dx over dt. So dy is sine t, so dy over dt is going to be just cosine t, and dx over dt is going to be negative sine t, because x equals cosine t over here, so we'll have negative sine t. So from here I can conclude that my dy over dx equals to dy over dt over dx over dt. So in this case, cosine t over negative sine t. Okay. So what we did, we derived the formula for the slope for these parametric equations. Okay, our next goal to answer for which t I'm gonna have horizontal tangent lines, and for which t I'm gonna have vertical tangent lines. But in this case, we can see that we have horizontal. What does it mean, horizontal tangent lines? That if I have a graph, my slope is 0. So I want to find for which t this part, the right-hand side, is going to be equals to 0. But this is going to be true if only the top part equals to 0. So I want to know when my top part equals to 0. And again, this is going to be for my horizontal tangent line. So I want to know where is cosine t equals to 0. But in the case when I want to find vertical tangent lines, I want to find the tangent lines of this form, when my tangent lines are going to be parallel to y-axis. But in this case, we can see that our slope is infinite or undefined. And when do we have that our slope is undefined? We have this exactly when my bottom part here going to be equals to 0. Because in this case, 1 over 0 going to be equals to infinity. So in this case, I'm looking when sine of t equals to 0. But from here, I can conclude that cosine t equals 0 exactly when t, according to the trigonometric circle, equals to pi over 2 or 3 pi over 2, which we can see exactly correspond to these 2 points, pi over 2 and 3 pi over 2. And my vertical tangent lines are going to be exactly when sine of t equals to 0, but this is true when t is 0 and pi. And this exactly corresponds to this tangent lines. So we got our final answer. Okay guys, thank you for watching. In this video I show you what is the formula for derivative of parametric equations, and I show how to use this formula to answer what are horizontal and vertical tangent lines for our parametric curve. Okay, thank you for watching. I hope you enjoyed this video. If you're not subscribed to this channel, please subscribe. And in the next video, I'm going to show you more calculus with parametric equations. Thank you for watching.